Have you ever wondered why a swing keeps moving back and forth? Today we dive into the fascinating world of pendulums. So, what exactly is a pendulum? A pendulum is simply a weight suspended from a pivot point, free to swing back and forth. At the top, we have the pivot point, the fixed point from which everything hangs. The string or rod connects the pivot to the bob, which is the swinging mass at the bottom. And when we give it a push, swing! Watch the magic happen. It swings back and forth in a beautiful rhythmic motion. Now, let's understand the forces that make a pendulum work. Two forces are constantly battling. Gravity. First, we have gravity. It pulls the bob straight down with a force equal to mass times g. This is the driving force of the pendulum. But here's the clever part. We can break gravity into two components. The tangential component, mg sine theta, is what actually makes the pendulum swing. That just pulls along the rope, and the tension cancels it out. Tension. The tension in the string always points toward the pivot, keeping the bob on its circular path. Now comes the beautiful mathematics. Let's derive the equation that governs pendulum motion. We start with Newton's second law. Force equals mass times acceleration. The tangential restoring force is negative mg sine theta. Negative because it always pulls back toward equilibrium. The arc length s equals L times theta. And acceleration is L times theta double dot. And combining everything, we get the pendulum equation. Theta double dot plus g over L times sine theta equals 0. This is the heart of pendulum physics. For small angles, approximate theta is approximately equal to theta. This gives us simple harmonic motion. The pendulum oscillates like a perfect sine wave. How long does one complete swing take? Let's discover the period formula. Here it is. The period t equals 2 pi times the square root of L over g. Such an elegant formula. Notice something interesting. Only length affects the period. A short pendulum swings quickly, while a long pendulum swings slowly. Mass doesn't matter at all. Mass differed. Look at the formula again. Mass m does not appear anywhere. A feather and a bowling ball on equal strings swing at the same rate. Pendulums are everywhere in our world. Let's see some amazing applications. The grandfather clock uses a pendulum to keep perfect time. For centuries, this was the most accurate timekeeping device. Musicians use metronomes. Tick, tock, tick, tock. Keeping perfect rhythm for practice and performance. Seismometers detect earthquakes. The pendulum stays still while the ground shakes beneath it, measuring the Earth's tremors. Swing. And of course, playground swings. Every child experiences pendulum physics without even knowing it. Today, we explored the beautiful physics of pendulums. From the simple swing of a weight to the elegant mathematics of harmonic motion, pendulums reveal the hidden order in our universe. The pendulum keeps swinging, a timeless dance of physics and beauty. If you enjoyed this, don't forget to follow for more physics adventures. Thanks for watching. Follow for more amazing physics content.